Hello students, this is lecture number 4. In this lecture, we will study how to multiply two matrices. So, firstly we will see when the multiplication of matrices exist. Okay? Suppose I have the matrix A which is of order m by n and matrix B which is of order p by q, then the multiplication A into B will exist if and only if n is equal to q. Okay, now this is the basic requirement for the multiplication of matrices. Now what says the requirement? If we have the matrix A which is of order m by n and the matrix B which is of order p by q, then this multiplication A into B will exist if and only if n is equal to p. Okay, not q, it is p. Now what this means, where this n is a number of column in the matrix A and this p is the number of rows in the matrix B. Okay, so this is the basic requirement for the multiplication of the matrices. Okay, so what is the condition for multiplication? It is what? The number of columns in first matrix should be equal to number of rows in second matrix, then only we can multiply two matrices. Okay, for example, suppose I have the matrix A which is of order 2 and the matrix B which is of order 5 by 2. Okay, then the multiplication A into B does not exist because the number of columns in the matrix A are 2 and the number of rows in the matrix B are 5 and 2 is not equal to 5. This means what? The multiplication A into B does not exist. Second example, suppose I will take the matrix A which is of order 3 by 2 and the matrix B which is of order 2 by 4, then the multiplication A into B exists because the number of columns in the first matrix are equal to the number of rows in the second matrix, so that the multiplication of A and B, that is A into B, will exist. Okay, and from this we can see what will be order of the matrix A into B. Okay, if A is a matrix of order m by n and B is a matrix of order n by q, then obviously the matrix multiplication will exist because the number of columns in the first matrix equal to number of rows in the second matrix. So matrix multiplication will exist A into B, and the order of this matrix A into B will be m cross q. Okay, this is m and this is q. Okay, so the order of this matrix will be m cross q. For example, suppose I will take the matrix of order 5 by 2, matrix B of order suppose 2 by 3, then the multiplication of the matrix A and B will exist and the matrix AB will have the order 5 by 3. Okay, there is 5, here it is. Okay, this is 5 and this is 3. Okay, so that is what the multiplication will be. Okay, now the most important question is how to multiply two matrices. Okay, let A be the matrix of order suppose 2 by 2, A, B, C, D, and suppose B is again one of the matrix of order 2 by 2. Suppose that is P, Q, R and S. Then the matrix multiplication A into B will exist. Okay, because this is a matrix of order 2 by 2. Matrix A is of order 2 by 2. Matrix B is of order 2 by 2. And the number of columns in the first matrix equal to number of rows in the second matrix. So AB will exist and its order will be 2 by 2. Okay. Now question is how to multiply those matrices. Okay. So what we will do, we will consider the matrix A, that is A, B, C, D, and the matrix B, that will be P, Q, R and S. Okay. Now see what will happen here. Okay, we will get the matrix of order 2 by 2. Okay, means what? 2 by 2 means what? It will contain 4 elements. This will be the first element. Okay, this will be second element. This will be third element, and this will be fourth element. Okay, now how to find out this first element? Okay, that will be obtained using the first row of the first matrix and first column of the second matrix. Okay, so this will be obtained using R1 and C1 of the second matrix. Okay, then this entry will be obtained using the first row and the second column of the second matrix. So this will be obtained using R1 and C2. Okay, again this entry will be obtained using second row and first column of the second matrix. So this will be R2 and first column of the second matrix. Then again this entry will be obtained using again the second row and second column of the second matrix. Okay, so this will be like second row and second column. Okay, so this is what we will do. Okay, I will write it again. Okay, this is the matrix A, B, C, D. Okay, then this is the matrix P, Q, R and S. Okay, and how to multiply matrices? As I told you, the first entry here will be using first row, this first whole row and first column. Okay, so this is how we will multiply it. Okay, and see how to multiply it. Okay, so first row and first column. Okay, see what will happen. How to multiply this A, first component of the first row will get multiplied with the first component of the first column of the second matrix. Okay, so this will be like A into P plus now second component of the first row and second component of the first column. Okay, so this will be like B into R. Okay, now this is done. Okay, now second one, this is using first row and second column. Okay, see this, what will happen? This will be like first component will get multiplied with the first component of the second column. Okay, see what will happen? This will be A into Q plus then second component to the second component of the second column. Okay, so this will be plus B into S. Okay, now in this now, okay, we are talking of this now. Okay, now again second row and first column. Okay, component wise multiplication will be there. Okay, this will be like C into P plus second component of the second row and second component of the first column. So this will be D into R. Then again second row itself. Now see this one, second row and second column. So again first component with the first component of the second column. Okay, so this will be C into Q plus D into S. Okay, so this is how we will multiply two matrices. Okay, for example, suppose if I will take the matrix A equal to 1 2, okay, 1 2 0 3, and suppose the matrix B is 2 3 1 0. Okay, now question is whether the matrix multiplication exists or not. Now you need to observe what is the order of the matrix A. So order of the matrix A is 2 by 2 and the order of the matrix B is 2 by 2. So you can clearly see the number of columns in the first matrix equal to the number of rows in the second matrix. So the multiplication A into B exists. Okay, and see what will be the multiplication A into B. So put matrix A, that is 1 2 0 3, and the matrix B is 2 3 1 0. Now see what will happen. Now we need this entry, and this entry will be obtained using first row and first column. Okay, now see how to get it. Okay, so what we will do, first component with the first component of first column. Okay, so this will be 1 into 2 plus second component of first row, second component of the first column. So this will be like 0 into 3. Okay, now this entry, okay, how it will be, this will be like first row again, first row but second column. Okay, so this will be 1 into 1, okay, then 0 into this 0 plus 0 into 0. Okay, so we are done. Now think about this entry. Okay, this will be using second row and first column. Okay, now see what will happen. This will be like first component will get multiplied with this first component. Okay, so this will be like 2 into 2 plus 3 into 3. Then this entry will be using again second row and second column. Okay, see what will happen. This will be 2 into 1 plus 0 into 3. Now just take the calculation. This will be 2 plus 0 2, this will be 1 plus 0 1, then this will be 4 plus 9, 4 plus 9 is 13, and this will be 2 plus 0 is 2. So this will be our required matrix A into B, and you can clearly see the order of that matrix is 2 by 2. Okay, now suppose I'll take this one, this example. Okay, the matrix A is of order 2 by 2 and the matrix B is of order again 2 by 2. Okay, then clearly we can multiply the matrix A and B because number of columns in the first matrix are equal to the number of rows in the second matrix. Okay, so take multiplication. Now for this first entry we need to observe what is first row and first column. Okay, so take the multiplication component wise. So this will be 1 into 0 plus 3 into 1. Then about this entry we need to observe what is first row and second column. So take the multiplication component wise. This will be 1 into 2 plus 3 into 3. Okay, then we need to think of this one now, this entry which will be obtained using the second row and first column. So this will be 2 into 0 plus 4 into 1. Then again second row, second column. This will be 2 into 2 plus 4 into 3. Okay, so this is equal to, now take this multiplication. 1 into 0 is 0 plus 3. This will be 1 plus 9. Then this will be 0 plus 4. Then this will be 4 plus 12. So which is 3, 4, 10 and 16. So this is our required matrix which is of order 2 by 2. Okay. Now suppose we will take this multiplication. Question is find A into B if exist. Okay, now if you'll observe here, the order of this matrix is 2 by 2, order of this matrix is 2 by 2. Okay, so obviously the number of columns in the first matrix equal to number of rows in the second matrix, so the multiplication A into B exists. Okay, and what will be that multiplication? Okay, so consider A into B. Okay, so matrix A is 1 minus 1 2 0 and into minus 2 3 1 4. Okay, now which is equal to, take multiplication, first component, first row, first column. Okay, see what will happen. This will be 1 into minus 2 plus 2 into 3, then this will be first row, first column. Okay, so this will be 1 into 1 plus 2 into 4. Okay, then second row, first column. Okay, so this will be 1 into minus 2 plus 0 into 3. Then next entry, second row and second column. See what will happen. This will be minus 1 into 1 plus 0 into 4. So which is what? Minus 2 plus 6. This will be 1 plus 6. This will be 2 plus 0, and this will be minus 1 plus 0, which implies this will be 4, 2, 7 and minus 1. Okay, so this is our required matrix A into B, and which is of order 2 by 2. Okay, now again question is find A into B if exist. Okay, so for the existence of the multiplication of matrices, we need to check the order of both the matrix. This is the matrix of order 2 by 2 and this is the matrix of order 2 by 1. Okay, so obviously the number of columns in the first matrix equal to number of rows in the second matrix. So this will be A into B is equal to 1 3 1 1 into B 2 4. Okay, which is equal to, okay, so we need to multiply those matrices, and whatever matrix we will get, that will be of order, okay, what will be its order? 2 by 1. 2 by 1 means what? It will contain 2 rows and only 1 column. So this will be matrix like this of order 2 by 1. Okay, now for first entry, this is of order 2 by 1. Now for this first entry, what we will do? First row, first column. Okay, so this will be 1 into 2 plus 1 into 4. Okay, then there is no second column here, so we'll stop there. Okay, now second thing is what? Second row, first column. This will be 3 into 2 plus 1 into 4. So finally we will get this as 2 plus 4 and this as 6 plus 4, which is of order 2 by 1, which implies this will be 6 and this will be 10, which is of order 2 by 1. Okay, so this is how we multiply matrices when the multiplication does exist. Okay, suppose we need to multiply these matrices. Okay, firstly we will observe what is the order of the matrix A, which is of order 1 by 3, and this is a matrix of order 3 by 1. Okay, then we need to find the matrix A into B if exist. Now does it exist? So answer is yes, because the number of columns in the first matrix equal to number of rows in the matrix, and whatever matrix we will get, okay, that will be of order 1 by 1. 1 by 1 means what? It will contain only one row and one column, that is only one number. Okay, so let's multiply matrices. So consider matrix A 1 2 3 and matrix B, which is 4 5 0. Okay, so we will take multiplication. So first row, first column. Okay, so this will be 1 into 4 plus 2 into 5 plus 3 into 0, which is what? 4 plus 10 plus 0, which is 14, and which is a matrix of order 1 by 1. Okay, that's it. That is the multiplication of the matrices. Now we'll take one more example. For the multiplication, find the matrix multiplication A into B if exist. Okay, now whether matrix multiplication exists or not. So this is a matrix of order 3 by 3, this is a matrix of order 3 by 3. Okay, so matrix multiplication does exist, so A into B exists, and whatever multiplication we will get, its order will be obviously 3 by 3. Okay, so we need to multiply now. Now consider first row, first column. Okay, so let's see how to get it. 1 into 1 plus 1 into 3 plus 2 into 1. Okay, now the second entry will be again first row, second column. So this will be 1 into minus 1 plus 1 into 2 plus 2 into 0. Okay, now about third entry, first row, third column. Okay, so this will be 1 into 0 plus 1 into 1 plus 2 into 2. Okay, now next entry will be now this time this will be second row and first column. Okay, so this will be 2 into 1 plus 0 into 3 plus 3 into 1. Okay, now again second row, second column. Okay, so see this will be 2 into minus 1, then plus, this will be 0 into 2, then plus 3 into 0, then again second row and third column. Okay, so this will be 2 into 0 plus 0 into 0 plus 3 into 2. Okay, now last one is what? Third row now with multiply with the first column. Okay, see this will be like minus 1 into 1, then plus 1 into 3 plus 0 into 1, then this will be like minus 1 into minus 1 plus 1 into 2 plus 0 into 0, then again third row, third column, this will be minus 1 into 0 plus 1 into 1 plus 0 into 2. So let's take the multiplication and finish the answer. Okay, so see what will happen. This will be like 1 plus 3 plus 2, this will be like minus 1 plus 2 plus 0, this will be like 0 plus 1 plus 4, this will be 2 plus 0 plus 3, this will be minus 2 plus 0 plus 0, then this will be 0 plus 0 plus 6, then this will be minus 1 plus 3 plus 0, and this is 1 plus 2 plus 0, then this is 0 plus 1 plus 0. Okay, we will write the final answer, and the final answer is 1 plus 3, 4 plus 2 is 6, this will be 1, this will be 5, this will be 5, this will be minus 2, 6, 2, 3 and 1. Okay, this is our required matrix which is of order 3 by 3. Okay, now the next question is to find the matrix A square if A is given. Okay, now to find A square means what? We can take the multiplication as A into E, A, that is 1 2 0 1 into 1 2 0 1, which is equal to, now again first row, first column, this will be 1 into 1, okay, plus 0 into 2, then first row, second column, 1 into 0 plus 0 into 1, then again second row, this one, second row and first column, this will be 2 into 1 plus 1 into 2, then 2 into 0 plus 1 into 1. So finally we will get this as 1 plus 0, 0 plus 0, then 2 plus 2, then this will be 0 plus 1. So finally we will get this as 1, 4, 0 and 1. Okay, so this will be the matrix A square and our answer. Okay, now the question is to find the values for x, y, z. Okay, if this relation is given to us. Okay, so firstly, in the given relation we need to find the values for x, y, z. Okay, so what we will do first, we will take this addition first. Okay, it is an addition of 1 2 3 3 0 1 2 1 2 plus 3 1 2 0 4 1 2 5 0. Okay, and this addition will be, in addition we add the corresponding components. Okay, so this 1 will get added to this 3, so this will be 4, this will be 3, this will be 4, this will be 3, this will be 4, this will be 6, this will be 5, this will be 2, this will be 2. Okay, so we got this addition. Okay, now if you'll observe, this addition is multiplied with this column matrix 1 2 3. Okay, so we will multiply this addition with this column matrix 1 2 3. Now we need to observe whether we can multiply or not. Okay, for that we need to see what is the order of this matrix, which is 3 by 3, and order of this matrix is 3 by 1. Okay, so number of column in first matrix equal to number of rows in the second matrix. Okay, so we can multiply that matrix. Okay, and that matrix multiplication will be of order 3 by 1. Okay, that will be of order 3 by 1. Now see how to multiply. So obviously what we do, we take first row with first column. Okay, so see what will happen. This will be 4 into 1 4 plus 3 into 2 6 plus 4 into 3 12. Then now second row and first column, this will be 3 into 1 3, 4 into 2 8 plus 6 into 3 18. Okay, now last one, third row and first column. Okay, so this will be 5 into 1 5 plus 2 into 2 4 plus 2 into 3 6. Okay, so finally what we'll get, this will be 10 plus 12, that is 22, and this will be 3 plus 8 11 and 18. Okay, that will be 29. Then this will be 5 plus 4 9, and 9 plus 6 will be 15. Okay, so this is the matrix which is of order 3 by 1, and if you'll observe in the given example, this whole value, okay, this whole value is equated, this whole value is equated with this column matrix x y z. So this is equal to the matrix x y and z. So by equating, okay, so by, therefore by equating both sides, what we get? We get the value for x equal to 22, y equal to 29, and this z equal to 15. Okay, and that is our answer. Okay, now in this example we have given the matrix A, which is of order 2 by 2, matrix B, which is of order 2 by 2, and also the matrix C of order 2 by 2, and we have to show the matrix A into B is equal to matrix A into C. Okay, so firstly for this we will consider the LHS of the given equation. Okay, which is what? A into B. Okay, put matrix A, which is 2 2 2 and 2, and matrix B, which is 2 4 3 5. Okay, take this multiplication, this will be first row first column. Okay, 2 into 2 4 plus 4 into 2 8. Then first row second column, 2 into 3 6 plus 10, then second row and first column. Okay, 2 into 2 4 plus 8, then 2 into 3 6 plus 10 again. Okay, so this will be equal to 12 12, then 16 16. Okay, so this is a matrix AB and that is our LHS. Okay, now consider RHS. Okay, RHS is what? A into C. So A is 2 2 2 2, then the matrix C is 4 2 5 3. Okay, now take the multiplication. This will be 4 into 2 8 plus 4, then this will be 10 plus 6. Okay, then 4 into 2 again 8 plus 4, then this will be 10 plus 6, which is again 12 12 16 16. Okay, which is a matrix A into C. If you observe both the matrix, you can clearly see what? A into B is equal to A into C. Okay, and that is our required proof. Okay, now the next question is, if A is a matrix of order 2 by 2, show that A square minus 3A is equal to twice A. Okay, and what they are saying, this I is nothing but the unit matrix of order 2. Means what? This I will be unit matrix, means identity matrix of order 2. Okay, so we need to prove this. Okay, so we will again consider the LHS of the given equation. Okay, so LHS is given by, LHS is A square minus 3 times A. Okay, so A square means what? A into A minus 3 times A. Okay, now put the matrix A into A. So this will be 2 1 4 1. Again matrix A, 2 1 4 1 minus 3 into A. A is again 2 1 4 1. Okay, so which is equal to, now take this multiplication. This will be 4 plus 4. This will be 4 into 2 8 plus 4, then this will be 2 plus 1, then this will be 4 plus 1 minus, by scalar multiplication, this will be 6, 3 into 2 6, this will be 12, this will be 3, 3 into 1 is 3. So which is equal to 4 plus 4 is 8, this will be 3, this will be 12, this will be 5. Okay, minus this will be 6 3 12 and 3. Okay, now subtracting. Okay, so 8 minus 6 is what? 2. Then 12 minus 12 will be 0. Then 3 minus this 3 will be 0. Then 5 minus this 3 will be 2. Okay, now if I will take this 2 out from the matrix, so this will be 2 times 1 0 0 1. Okay, and that is nothing but our RHS. Okay, because what is RHS? RHS is what? 2 into I. 2 into I means 2 into 1 0 0 1. Okay, this is our RHS and hence the proof. Okay, now the next question is, we have given the matrix A which is of order 2 by 3 and the matrix B which is of order 3 by 2. Okay, and what they are asking, we need to show that the matrix A into B is a non-singular matrix. Okay, so for solving this you must know what means non-singular matrix. Okay, the matrix is said to be non-singular, that I have explained in the first lecture. The matrix is said to be non-singular matrix if the determinant of the matrix is not equal to 0. Okay, this is the non-singular matrix A. Okay, and what we have, we need to show the matrix AB is non-singular. This implies we need to show what? The determinant of the matrix AB is not equal to 0. So to calculate this, first we need to find out what is the matrix AB. Okay, so firstly we will calculate the matrix AB. So we'll write the matrix A first here, -2 1 0 2 1 3. Okay, and the matrix B is 0 2 1 then 1 3 1. Okay, now if you'll observe here, this is the matrix of order 2 by 3 and this is the matrix of order 3 by 2. Means what? Whatever matrix we will get, that will be of order 2 by 2. Okay, now take down the multiplication. Okay, so how to get it? First row, first column. Okay, see what will happen. -2 into 0 is 0 plus 0 plus 1. Okay, okay, so this will be like 2 by 2 matrix. Okay, so first row and first column will give you 0 plus 0 plus 1. Then again first row, second column. Okay, so what you will get? -2 plus 0 plus 1. Now next one is second row, first column. Okay, this will be 0 plus 2 plus 3, then this will be 1 plus 6 plus 3. Okay, so this is equal to 1, this will be -1, this will be 5, this will be 10. Okay, so we got this matrix A into B. So we will just try and find what is the matrix what will be the determinant of the matrix. Okay, so determinant of the matrix is nothing but determinant of 1 5 -1 and 10. Okay, this is the 2 by 2 matrix, so this will be 10 into 1 minus -1 into 10 into 1 minus -1 into 5. Okay, so this will be 10 plus 5, which is 15, and which is not equal to 0. This implies the matrix AB is non-singular matrix. Okay, fine. So this is enough for the lecture. In the next lecture we will study what is the determinant of the matrix, how to calculate the determinant, and what are the different properties of the determinant. Thank you.